Thank you for joining us for this video on working with geometric sequences and series, doing work without a calculator. These are the practice problems for Module 2B, Day 3. So, first problem, we're asked to determine if the sequence is geometric and to provide reasoning. So, if we look at our term to term and we notice that we are multiplying by the same thing each time, all right, so we're multiplying by times 3 each time. Then we can say we have a common ratio of 3. Therefore, geometric, right? So our reasoning is we have a common ratio, and that means that we're geometric. If I look to B, this one is times 4 to get to 12, right? But then if I look 12 to 21, that's not going to be times 4. Right? And if we say, hey, how do I get from 3 to 12? I could also say addition from 12 to 21. That's addition, right? So we are not geometric, and the reason is there is no common ratio, right? In fact, for this one, we know that instead we would be arithmetic with a common difference of 9. All right, if we look to the next one, 1, negative 1/2, 1/4, negative 1/4. All right, we can also do this work by division, right? We could say, hey, negative 1/2 divided by 1 is negative 1/2. 1/4 divided by negative 1/2 is going to be negative 1/2, right? And negative 1/8 divided by 1/4 is going to be negative 1/2. And if that is the case, then I know that I have a common ratio of negative 1/2, and that means I have a geometric sequence. Once again, sequence has commas. All right, if I look to my next term over here, another way that you might do it is to say, hey, what is my general term? And this general term seems to be negative n, negative 1 to the n times let's say negative 1 to the n plus 1 all over n. That would give me a positive number to start, and then over n, that seems to work. And so we have no common ratio, and so we're not geometric. Okay, so make sure that if you're asked to provide reasoning, that you do provide reasoning. Continuing, we want the first 5 terms of a geometric sequence, and we have the first term in the common ratio. So the first term is 2 times 3 times 3 times 3, right? And then 54 times 3. Well, we know that 50 times 3 is going to be 150. We know that 4 times 3 is going to be 12, and so we're going to have 162. All right, so those are the first 5 terms. All right, for this one, first term 5, the common ratio 1/2, so I have 5, then 5 halves, then 5 fourths, then 5 eighths, then 5 sixteenths, and those are my first 5 terms. I'm just multiplying through. All right, we have our geometric sequence, and once again, separated by commas. For number 3, we want a formula for the nth term of the geometric sequence and the value of the indicated term. So, if I know that my geometric sequence starts with 16, I know that my given term can be 16 times 1/2 to the n minus 1. Why do I have n minus 1? Well, because if we start our counter at n equals 1, I need that first term to be 16. So that means that the 10th term has to be 16 times 1/2 to the 9th power. And so that's going to be 16 over 512. I do not need to simplify. I do not need to simplify. How can I know about 1/2 to the 9th is denominator of 512? Well, I should know that 2 to the 10th is 1024, and so I take half of that. That would be 512. Another approach could be to say, hey, if you know that 2 to the 6th is equal to 64, then you could say 2 to the 7th is equal to 128, 2 to the 8th is equal to 256, and that would give you 2 to the 9th be 512. Don't care how you do it, but you need to understand your math facts. Okay? And if we look to the next one, we have our first term 100, and we got this weird common ratio, but that's okay. We can still do our work, right? Our nth term is going to be our first term times our common ratio raised to the n minus 1 power. That's fine, right? And then that ninth term is going to be 100, right? E to the x raised to the 8th power, 9 minus 1. And so that ninth term would be e to the 8x, right? If I am using my power to a power, I know that I can multiply. So a little stranger one here, but it's one that we need to be familiar with. Okay, and that is the work without a calculator. Okay, in the next video, we'll look at doing some work with a calculator and some additional practice on summations that are geometric. So make sure you can do this level of problem without a calculator. Thank you for your time.